Hello curious minds, welcome back. Let's build our first machine learning program in SageMaker with a proper graphical user interface. This is part of our continued journey to become a generative AI professional, and just in case if you don't follow any concept, then I would recommend you to visit our previous session where we have explained everything with a very simplistic approach. For now, let's create a JupyterLab where we are going to create a Jupyter notebook. Now remember, as soon as we create a JupyterLab, there will be an instance that will be created here. There will be a cost that will start incurring. Okay, so that is an important thing to remember. Let's click this. JupyterLab, it says create JupyterLab space. Let's call the lab space as my Jupyter lab space 1. Generally I prefer having a suffix with a number, and let's create the space. We are going to keep everything as default, and the important thing, the instance, it says MLT3 medium, right? Now there are a lot of machines that are available to us. How do we want to configure our development machine? We can have a tiny development machine and a large training and evaluation machine, right? But let's say if we don't want a tiny development machine, our notebook itself is going to be very heavy. So we can choose the machine from here, right? ml.t3.medium. This is just a logical name, simpler name. This machine will have 2 CPUs and a 4 gigabytes of RAM. We can change it to 8 gigabytes of RAM with MLT3 large, then MLM5 large, and so on and so forth, right? For now, we will use the default one. Let's click on run space and create our tiny development machine. Okay, it is setting up the machine for us. The status is starting. Let's give a minute. So our tiny machine is ready, and before we go to our JupyterLab, let's take a look at the running instances. Right? You can see that my JupyterLab is running, right? And there is an option to stop it as well. So when you stop the machine, that is the time when you will stop the incurring cost. Again, we are into the free mode as of now. We don't have to worry that much about the cost at this time, but we have to be careful of everything that is going to incur a cost for us. All right, so let's go to JupyterLab and let's launch it. It will open in a new tab, and this is very similar screen that we have seen in our local installation as well. Let me close this small items here. Okay, now this Jupyter screen is very similar to the Jupyter that we have installed in our local. We are going to repeat the same thing that we did in our local. Only difference will be we will be doing it into the aws SageMaker. And when I say repeat, don't worry, we are not going to rewrite the whole code. Instead, we are going to simply upload the existing code with this tiny arrow. Let's click the notebooks and say open. Okay, we should be able to see the notebooks being uploaded here in a while. All right, they appeared here, right? So let's double click our notebook. And if you remember, this is the same notebook that we did in our local installation. All right, all of this code is re-executable in this AWS Jupyter version as well, right? So let's run this one more time and see if it is working or not. Okay, remember, to run the cell you have to hit the shift enter. That's what I am doing on my screen, on my keyboard. Run the objective, first cell, keep running, Let's see, it's imported. Okay, let's see if it is able to, every time it runs the cell number will change. And if you want to be double sure that you are executing this cell again and you are not seeing the output from your previous version, you can always go to the edit menu and say clear output of all cells. As soon as you clear the output of all cells, all you will see is the code on your notebook. Let's clear the output. All right, what are the differences that we see? There are cells, no output, and then there are no numbers attached to it as well. That means that this cell is not executed yet. Let me click this and let me put shift enter. All right, executed. You see the number 4 appearing here. That means this cell is executed. Here is the output. There is a blank cell here, blank square bracket, which means that this cell is not executed. Let me execute it with shift enter. Okay, let's continue the journey. All right, all our 4 graphs are again here. Let's create the model. Let's create the model variable, and we printed where our model file is present. Let's see. So our linear regression algorithm file is present now on this machine, right? Now remember, we are in the AWS cloud, which means that this is no more a Windows machine. Instead, it's a Unix machine, right? If you want to be sure, you can go to File, New, and instead of notebook, this time we'll create a terminal. If you remember from our Windows exercise, this was opening a PowerShell terminal. Here it has opened a Unix terminal. So if we do which $shell, it will tell us that we are using the bash shell. Okay, going back to the notebook. The next thing that we wanted to do is to deploy our model, right? There is no pickle file at this time. So what we will do, import joblib is the library that we used last time as well, and we will say joblib dot dump, and the model that we are going to dump, which is called as model, now I'm going to call it as my fitted model.pkl, pickle, right? Let's hit shift enter, and a typo, let's correct it. Another typo, that let's correct it too. All right, there should appear a file here. There you go, right? So this is our deployed model, which is able to accept input as an integer and predict the value based on the current trend. All right, now that we have the .pkl file with us, we are now ready to run the GUI Python file, right? Let's do a quick view, and let me minimize this and let me increase the font size. So for that we will go to settings, setting editor, and here we will look for text editor, and we will change the font size to, let's say, 14. Okay, and we'll just save it by clicking somewhere else. Then we'll come out of this just to make sure that this overrides, close it, and hopefully, yes, this is a little better. This is an increased font size. Let's go back to the file browser. Now let's review our file. Import joblib loaded model. We are loading it from // linear regression deployments. Now if you remember, in our local, our file was present here. / takes us to the parent directory, and then linear regression deployment is the other directory where we kept the file. Okay, so that is the naming convention of navigating through directory. In our case here, our fitted model.pkl is in the same place where our Python file is present. So we don't need to go one level up in the directory structure. So instead of .. we'll just use one dot, which means go to the current directory, and inside the current directory you won't find linear regression deployment. Let's remove it, and let's say myfittedmodel.pkl. So this basically means that load the model from current directory with this dot symbol, and inside the current directory you will find a file called myfittedmodel.pkl, which is this. Load it. After loading the model, we will keep the rest of the code as same. Let me save the file. When you see this dot, which means this file is edited but not saved yet. For the rest of the file, you can see that there is a cross. They are non-edited, right? If I go to file and save, you will see this dot will disappear. There you go, right? So these are little tricks, you know what, when we work, these are tiny things that we don't pay attention to, but these tiny things will help us a lot when we are going to work in the real industry. All right, so my integrated GUI is edited as we like. We are now ready to run our Streamlit application like we did last time. So we will come here and we will come to the terminal. Let me remove this and let me clear the terminal, and we will print the path where we are with the command pwd, which means present working directory. So we are in home SageMaker user. If we do ls minus lrt, it will print all the directories that are present at this time. So we can see that our fitted model is also present here. We can also see that our integrated GUI.py file is also present. So we are good to run this file, and when we run it with Streamlit run my integrated GUI.py. When we run it using Streamlit, the requirement is on this machine where this terminal is running, the Streamlit should be available, right? It should be installed. And since we have created this machine altogether new, the Streamlit probably will not be present. So when we run it, we will get an error. Let's see. All right. So it says Streamlit is not a command. So what we will have to do here then is we will have to say pip install Streamlit. Let's install Streamlit first and then make use of it. All right, it says Streamlit installed. Let me go back to the top of screen. Let me clear the screen. And now with the help of up arrow, I can use the previous commands. So let me go to the previous command with up arrow instead of typing it again. So I'm saying Streamlit run my integrated GUI.py. Let's hit enter. All right. So it says that Streamlit application is started. You can view the application in your local host or at this IP or in the external URL IP. Now here is one of the most important thing of running Streamlit in AWS environment. Remember when we installed Anaconda in our local, we installed Streamlit in our local, and then when we did Streamlit run my integrated GUI.py, everything was in our local, right? In fact, Streamlit was able to launch a browser for us automatically as well. The difference that we see here in AWS is when we run Streamlit run, it does says that the application is running, but it has not opened a new tab for us. The only reason is this whole Chrome is running in my local. If I create a new tab, this tab is in my Windows local machine. It is not on the AWS machine. When it says Streamlit running, then this is running on a remote server on that tiny machine that we created. On this tiny machine that we created, my JupyterLab WorkSpaces 1, right? And Streamlit by default is not able to launch a browser on that machine. So the solution to access the Streamlit application is you have to copy this URL, you create a duplicate window, and we will paste this and instead of default lab, you will go to proxy and then say 8501 slash. Please do not forget to miss this trailing slash, otherwise you will see a blank page and then you will be confused where is my Streamlit application. Okay, let me hit this and see if we are able to see the Streamlit application or not. All right, this is the very same screen, and now if you observe, the URL is our domain.studio.the region.sagemaker.aws and then the whole URL. This is different from what it was there in our local, right? So this is the difference which we have to remember to make the Streamlit application run in our AWS SageMaker environment. Now finally, let's see if we are able to predict the value of y when x is 50. And it gives us an error, and let's see. Let's go back to our lab and let's see the notebook. Did we forget to fit the model? Oh yes, I think this is a good learning, right? So if you see, we created the model and we directly dumped it into a pkl file. We do not want to do this. Where is our fitting? Where are we fitting our data to the model? This is where we fit. Okay, so let's run this shapes. All right, now this is fitted. Let's see if we are able to predict some values. If it works in JupyterLab, it should be able to work in our integrated GUI as well. Now this model variable knows what our data is. It's a fitted model, right? So let's run this import joblib and joblib.dump. The difference between previous dump and this dump is when we did the dump last time, the model was not fitted. That means the model does not know what our data is. And if it doesn't know what our data is, it doesn't know this line, how to fit it, this gray line, right? It doesn't know the actual blue values. It doesn't know the line it has to fit. And how can we expect the model to predict the value of y when it doesn't know anything about our data? So now given that we have exposed our data to the model, which means that we have fitted our data to the model algorithm. Now our model knows that these are the actual values. This is my fitted line, and let's dump this model now, right? Let's run it one more time. If we go here, it should say model, my fitted model 1 second ago. That means it's a refreshed file, right? And if we go to the terminal again, right, we will have to start the Streamlit server one more time. So what we will do is we will press Ctrl C on our keyboard to stop the server, and then let me clear the terminal and we will rerun the application with the help of an up arrow. Alright, the application is again running. The only difference this time is it has now the model which knows our data, unlike the last time. Alright, let's refresh this page one more time. Okay, and let's try to predict the value of y when x is 50. Okay, so when x is 50, the predicted value for it is 273.4. Now this is a very small demo of how we can use linear regression to predict the value of a particular variable based on existing trend. Alright, so with this, we are able to run our Jupyter notebook in a AWS SageMaker environment. We are also able to see what SageMaker exactly is, what are the different services, different features that AWS provide to us, and we are going to see all of those features in a detailed video in the upcoming time. Okay, and before we sign off, remember it is not our local computer who is running this program. It is a machine which is running in an AWS environment. Even if it is free today, we do not want to incur any cost. Let's follow the best practice. So what we will have to do as a best practice, we will kill the terminal with a Control C. We'll go to file and we will say log out. All right, so this is logging out of our JupyterLab, and here if we go to the running instances, we see that the service is still running, that our machine is still running. We have used this machine for 26 minutes. Not a big cost, honestly. Even if you get to paid version, it's a tiny cost, right? But importantly, it's a cost. We do not want to incur any unwanted cost. So let's stop the machine. And as soon as you click the stop, you don't have any machine running. All right, if you go to home and again back to running instances, you see no running instances. This is the most important thing you have to remember before you log off from our SageMaker. You can go to management console, say sign out, and we are back to the sign in screen. So this is how we want to stop every service in the SageMaker unless we want it to be running. It's not necessary that we have to stop the service every time. If we want some job to run overnight, you just keep the service running. But for any unwanted services, we want to stop the service, do a proper log off, sign out of the AWS, and then we will sign off with this session as well. Good to be working with you guys. See you in the next session.